Congratulations, you have successfully completed your first artificial neural network. Now we are going another step ahead. Now we are going to learn convolution neural network. What is convolution neural network? Convolution neural networks are those neural networks which contain at least one convolution layer in it. At least one. Convolution neural network are very important, or CNNs are very important from machine vision problem point of view. So let's see what convolution layers means. Convolution layers are, in simpler term, convolution layers are those neural network layers which take some input image or input array. It applies some filter on top of it, and it transforms those images and produce the output images for each and every filters. So it is taking one input, it is applying multiple individual filters on top of it, and for each and every filters it is producing one output. Okay, so it is taking input, it is converting those input, transforming those inputs, and it is creating multiple images. Alright, so let's see how it works. Alright, so in this is done. We are going to use the same data set for these CNN only. Okay. Convolution neural network. Alright. So what happens here? Suppose you have one image. This is a 28 by 28 image, 28 pixel by 28 pixel. Now we have three different filters which we want to apply on top of it. Sometimes these are also called kernels. Okay, we are applying these filters on this image, and we are getting three output images, mostly on for the same size, or sometimes the size may vary depending on your criteria. So as of now, let's assume that it is going to produce same size image. So we are going to get three separate images from this one image, and each for these individual filters. So let's assume this is 1, 2, 3. So for each of these filters, we are getting one transform image. Normally for the initial layers of convolution neural network, they learn simpler geometric figures using those filters. These filters are mostly 3 by 3 or 5 by 5 or 7 by 7 or 11 by 11 in some extreme cases, and mostly 3 by 3 or 5 by 5 the pixel size. Okay, and they will try to kind of learn some. For example, this thing will try to learn this first filter like this. Third filter will try to learn something like this, and second filter will try to learn something like this. Okay, so it can have many number of similar filters or kernels. Okay, normally we check like 8, 16, 32, 64, and to the power of 2. This sort of counts for convolution neurons. Okay. And to be a little more kind of in detail, so let's see, we are predicting 7 through this. So this particular filter will try to recognize any vertical line in this image. Okay, so the output will have the higher pixel values wherever it is finding this particular shape. So the output will have something like this. This particular image will have, okay, maybe something like this. It is straight for this and this small one for this. The second one will have, will try to look for any vertical line. Okay, if there is no vertical line, so but some values randomly they will get, but I'm assuming that nothing will come out of this image. Okay, or maybe the whole image will have some small values like this. Third one will have, okay, to make it, let me correct it. Okay, assume third one will try to learn this diagonal angle. So third one will say this. This way, all these filters will transform this single image and will produce multiple images for the exact feature which is carried by those individual filters. And we can apply another layer of convolution neurons on top of each of these transformed image. So from this particular shape, you are going to get another 3 or 4 or maybe sometime 200, 300, 400 different images. And same thing will be applied to here also. Another set of 200, 300 images. And this way it will go exponential. Alright, so this section is pretty clear. Now, like network point of view, how it looks like. So we have single channel image of 28 by 28. From here we are applying a kind of 3 by 3 filter and assume for total 4 filters will apply. Okay. So the output from this particular image after the convolution layer will have 28 by 28 and it will have 4 channels. Okay, similar size, total 4 images will be there. 1, 2, 3, 4. Let's assume these lines are image. Total 4 images will come. Okay. And next layer, if you are using the similar sort of filters, number 4, so each of these will create another 4 layers. So that will have total 16 different images, which will try to learn different kind of features. This particular concept is called convolution operations, and that is done through convolution neural network. Okay. So now, question is how this 3 by 3 filter is being applied on top of this particular image. So let's talk about the convolution operation, how it works. Okay. So before I jump into this convolution operation, so there are 2 important terms you need to be familiar with. First one is kernel size. You already know that. Or filter size, or whatever term they are using, but this means the size of the filters. Okay, so let's take it 3 by 3. Okay, another term is that strides. Okay, strides are those values, pixel values, or the number of pixels it is going to slit through the image from the beginning position. Another important term, I will come to this padding term little later. Okay. So let me draw this image a little bigger, and I'm reducing the number of pixels for our simplicity. Okay, so assume this is a 8 by 8 pixel. Okay, bear with me for some time. This is 8 by 8 pixel. Okay. Image we got of size 8 by 8, and all these cells contain some values. Now we have a filter of 3 by 3. Right? So we want to apply this particular filter on top of this image. So what will happen? So it will start. This will start from this point. Okay. So this cell, these filters first will be applied for this 3 by 3 block. 3 by 3 block, it will be applied. Okay. And the value, whatever value it is getting, the linear multiplications values, it is going to. Okay, so it is going to whatever value it is getting, it will be placed here. Now, on the basis of this strides value, that means 1 row, 1 column, this image will be shifted toward right, 1 by 1. Okay, so the next value, next set of patch would be this. It is shifting toward right by 1 pixel, but it is not going down yet. So whatever value it is getting from this second patch, it is going to place it here. Once that is done, it is going to value it is getting means the linear multiplications. The next thing, it is going to slit toward right once again. So it is going to have another set of patch till it is reaching to the end of this image. Okay. Whatever content it is getting from this operation, these sections, it is going to place here. Okay. One important thing, just notice that image, the patch is stopping when it is reaching to the end of this image. It is not exceeding the image. Okay. So once it has reached to the end of this boundary, it will go down. So next set of patch, once we have all the, we have done for the first 3 rows, it will go down by 1 pixel. So this is the another pixel. So it will do this operation, convolution operations or linear multiplications for simplicity. The operation may be a little more complex. Okay. It is going to take the content. It is going to place here. This way, it is going to cover all the pixels, and it is going to calculate the convolution values and till it is putting everything here. So one important thing you might have noticed here, that from this 8 by 8 pixel, it is able to generate 6 by 6 pixel image. So because we are limiting the patches till the end of our images. So there is another concept which will come, that is called padding. It can take 2 values, same or value. Okay. If the padding is by default configured normally for most of the frameworks as valid. So if we are applying these 3 by 3 filters on top of these 8 by 8 image, it is going to produce 6 by 6 image by default. So if you want the same size image as output from the transformation process, you have to mention the padding as same. In that case, what it is going to do, it is going to create some pseudo rows and columns or values. There are some other mechanism, but for simplicity, let's assume they are going to add 0 as the first row, blah blah, something like that. and it is applying the image, the patching from here till here, and it is calculating the value for this particular cell and it is putting somewhere here. Okay, so this padding 0 is this particular 0 padding is done using the same. This number of rows and number of columns largely depend on the patch size or content size. If it is 5, then it will add 2 more rows and 2 more columns in this case. But this is how it works. Strides means the number of pixels it is going to shift toward right or toward bottom. Content size is majorly the size of the filter. Okay, so from this image we are going to convert it to another image applying the filters. Okay, and if we have 64 different filters, we are going to get 64 different images from this single image. Next important thing, in the same context, I think we are done with this convolution operation. There is another critical operation which is closely associated to this convolution operation, that is called MaxPool layer. What happens here? Whenever we are applying any MaxPool content operations on top of any image or on top of any array, it is going to select a pool size from the image. It is going to select a pool from the image and it will pick up the maximum of those pixels or those cells or those pool of array. Okay. So I will clarify it once again. So that is separate operation, that is something called MaxPooling. So let's redraw it. Bear with me for some time. Okay, so what happens here, and I'm reducing the pixel size to, let's make it 8 for simplicity. Alright, this is 1 8 by 8 pixel image. I'm going to apply a MaxPool operation on top of it. The important parameters for MaxPools are pool size 2 by 2 and strides 2 by 2. By default, whatever pool size we have, we choose the same slides or strides also. How it works, and assume this is the output image. How it works, it is going to select a 2 by 2 patch from here. This is 2 rows and 2 columns. It is going to select this patch and it will find the maximum values for those 4 pixels. Okay, for example, suppose this contains 0.1, this contains 0.2, this contains 0.4, this contains 0.6. The fourth cell contains 0.6. So it will pick up that 0.6 and it will place in the new transformed image. 0.6 is the value for the first cell. And then it will take the slate row, slate column, and it will start sliding toward right till end and then bottom till end. So next what it is going to do, it is going to pick up this particular pool and it will try to find out the same maximum value for those 4 cells. Whatever maximum value it is getting, it is going to place it here and so on and so on. Okay, till it is reaching to the end. Same padding concept is there. But the purpose of this MaxPool is to kind of reduce the image size so that we can control the number of content or number of elements or input values in our operations. So what is happening here, from these 8 by 8 pixels with this pool size of 2 by 2 and stripe 2 by 2, we are getting one new image which contains 4 by 4 pixels. Oops, 4 by 4, representing the same values. If we have some, whatever the boldest pixels, we are going to pick those contents and we are going to place it here. Okay, so from a bigger dimensional, bigger image, we are going to reduce the image size to our controllable format so that we can do further dense operation or flatten operations or any sort of fully connected operations on top of it. Okay, normally how it works, we have image, we are applying convolution layers first. Maybe multiple convolution layers, 2 or 3 consecutive. Then we are applying MaxPool, we are reducing the image size. Then we are applying convolution once again, 2-3 more convolutions. And then we are applying MaxPool till we are bringing down the size of the image into some acceptable formats, depending on kind of project you are doing. Some cases you have to kind of UNIT or ResNet or retina net, some advanced machine vision models you will hear later. So multiple layers of convolutions and MaxPools are arranged together so that we can bring down the initial number of inputs to some acceptable and controllable number of inputs. Okay. By the way, this is the whole concept of MaxPool operations. You still have that padding operations if you want, it's valid and same. Slate is almost common, but in this case, MaxPool operations, we are going to pick up the slate size as MaxPool size in most of the cases, and depending on your requirement or your experiment. And pool size is normally 2 by 2, and you can make it 3 by 3, 4 by 4, whatever it is, whatever you are comfortable or if you are interested to apply. But this is the whole operation for convolution neural network, MaxPool operations, and this one. Okay, so now we are going to implement these convolution layers and MaxPool layers in our classification problem for image digit recognition. Okay, let's jump into our coding sections. Let's try it by our own, and you can